Okay, you can see the screen, right?
Yes, sir.
All right, we'll start NLP. Start with basics. It's already been explained, label and label. So we'll focus on this part. All right, we'll start with count vectorizer. Basically, like when we have, let's take, let me start with this. So suppose, what is the character? If a single word, a single letter, right? Suppose if it is group of letters, what do we call it as? A word.
Word.
A group of words
Sentence.
can be a phrase or a sentence. Phrase in the sense, two words or three words combined together, we call it as phrase, right? A group of sentences, paragraph. Group of paragraphs, called as document. Group of documents, we call it as corpus. So you hear this word documents or corpus quite frequently in NLP or generative AI. What does that mean? Corpus nothing but a group of bunch of documents. Okay, so we are training it on corpus, and this is the model that we got, and so on so corpus. So this is what it means. They're trying on certain bunch of documents. That is what. Let's consider that I have used count when we have text data like this. No algorithm or neural network right now, at least, can't understand any text related data. Suppose this data being fed directly to algorithm, machine learning algorithm, or even neural network is not going to work because this is text data. Neural network or machine learning algorithms can understand only numbers. Then how best we can convert this into numbers? Like how do we even convert into numbers? And what are the ways that we can convert into numbers? Right? For example, let's take that each sentence here, consider that is a document. Okay. So there are 4 documents in this list. Even there is nothing wrong in considering it as sentence. Just consider that it's each sentence here as a document. We have something called count vectorizer that we can import from scikit-learn feature extraction text. Okay, so that we can just, it's like any other algorithm. Even for pre-processing, we can simply create an object and then apply on that. So we can feed this corpus. But the only difference between the way we generate the models compared to this pre-processing kind of models is fit transform. We are transforming the data straight away here. Whereas in machine learning, when you want to generate a model, we usually use only fit. Fit is only to train and generate a model. Whereas this one is going to train on this and apply on the data directly, whatever that it has learned. Okay. So this is going to generate, so it's going to take every word and it's going to generate into some numbers. And the two array need to be used, two array method need to be used to get it in the form of array. By default, this X is going to indicate certain location. So some metadata related. So this will give the complete array. Of course, it doesn't make much sense. You will understand better so when you combine with column names. So the same vectorizer, after it got trained, it spits out the column names in this form with this method. Get features names out. So when we can combine both array and the columns, right? Using data frame. To combine it, you can see that each unique word being converted into column here, right? It's exactly what has happened. And in each document, if you look at this is the first document. So do we have and here? 0. Do we have document here? Yes, we do have 1. How many times it has been repeated? Only once. That's the reason we got only 1. First we have, yes, we do have first only occurred only once. Do we have is here? Yes, we have is, so 1. Do we have 1 here? No. Second here, in this first document, no. And the, yeah, we have. At the case insensitivity, this is. So you can see internally it has been converted into case and lower case altogether. Third, we don't have third. And we have this, so we do have this. That's the reason we got one. If it, you can see the second document interestingly I have written it like repeated 3 times. We got 3 times. So this data set we're going to feed to algorithm, not this data set. Okay, got it? There are better ways to do that. We have something called TF IDF factorizer, word to wake, glow, and we have neural network based embeddings. So right now we are in the initial stage, right? We just started NLP. Any questions on this part?
No, sir. Understood.
Okay, the next one is something called remove stop words. So stop words are nothing but it's going to be like this. I, me, my, myself, we. When we provide some input, right? This data. So let's take that Google, you went to Google, google.com. You mentioned what is machine learning, right? What is machine learning? So it's not going to take every word. It may take only machine learning. That's going to give us, or it may get rid of these ease word, which are nothing but stop words. Why it's going to do that? Because it's an overhead, right? So millions of users connect to the servers. So every word counts, every letter counts. Then if we get rid of these stop words, which doesn't make any sense, and at least when we, in terms of getting output from the server, then we can get rid of it. Those lists we call it as stop words or else noise words. We can otherwise call it as noise words. How do we delete that? I mean, how do we get rid of the, let's take when we have a lot of data here, you can see that a review column is going to have a lot of around 404 rows. No, not this one. Let me load this back again. File not found error. Don't we have that? Yeah. Okay. So let me go to data sets. So all this data sets. Yeah. So I can see data set now. What is the shape of it? 404 rows. Yeah, it has 404 rows. First. So the input column is review and the output column is label. So forget about output column now. We're still in pre-processing phase. So review column has this, each row has a document. Okay. If you look at 0, that is first row, you can see that is a document. And second row and so on and so forth. Each row is a document. Okay. On this, like the way we can need to get rid of the stop words is we have something called analytical library. So for the first time, when you may not have this analytical library, you need to use pip install analytical library. You can import like this. But thing is that if you want to get stop words or any other component, this library by default does not come with all the components because it's a very heavy one. So what it does is we need to download this using analytical library. We can download those components. Stop words here. It is only for the first time. For first time when you use that in your mission, you need to execute this one along with this one. The second time, you don't require this. You can comment this part. Okay, let me import it. These two things already imported, download it. So I don't require this. Even if I execute this one, it say that it's already been downloaded. It's already up to date. If it's not, it's going to download it. Now we have this something called stop words, which is part of NLTK.corpus. We need to mention the language that the list you want. For example, English, I got these words. Whereas Espanol, I think it's Spanish language. I don't know this language. Um, NLTK, stop words, languages. Yeah, here we have. So I think this is the way to get it. Where is it? Yes. So not available. Sorry, maybe fields or maybe stop words. Let me check what I have. Uh, okay, I think it is coming on top of this. That could be the reason. I'll do one thing. So yeah, here we have. Yeah, here we have this one. Okay. Because I have given the same name that created the ambiguity. So I will give us a different name. Yeah. It is replaced with this list. So what do we have here? These are all the language that it supports. Even we do have Spanish, then why it's not working? Maybe I executed twice, right? That could be the reason this stop words not available. If you look at this stop words one now, it gives all the noise words in Spanish. Okay, you can give any language you want. So in my case, I can use stop words now without because it's I given a unique name, right? It's English or Turkish. So noise words in Turkish, right? Let me go back with English itself. Now the important part comes in. So how do we get it? So we have the list of stop words. We need to use apply method on this column. So we need to get rid of stop words on this whole thing, right? So we have a lot of sentences. Thing is that even before this, we need to split this data into, for example, let's take review column, right? So we need to do is, all right, so let's take the same thing and we need to each word is basically we need to split this thing. Row dot split. Let's check the output and then we will go back to that one. Um, so basically lambda row for okay, so why can't we apply? So we need to loop it to every row, isn't it? Forgot the logic behind it. Let me use not this one. Okay, maybe this one. Yeah, so we need to split into this. We can use split this here in this way. So we have converted this to lower, and then we replace all the special characters with blank space, and then we split it. Okay, so let me load this back again. So here we have, okay, don't worry about HTML tags. We will focus on stop words. We've imported the stop words, right? The way this logic is going to be like, apply is going to loop every row. So in each loop, it's going to be each row. We already converted this into list of words, right? If you check this one, df dot review, this is not a row, typical row. It's a list of words. Every row is a list of words. So every loop is going to be one list. Okay. This X is going to be in first loop is going to be this list. Second loop is going to be this list and so on and so forth. Here, we are using lambda function. This is going to be like a parameter. So in every loop, So each row list is going to be as a parameter. So there's going to be fed here to for this for loop. So when we loop it again with for, what happens? We're going to get each word in each loop. Again, loop, apply is going to be a loop. And again, we are using another for loop. So two for loops, in fact. And in this case, we get word. But we are not directly feeding this word, and we are not taking this word as it is. We are what are we trying to do here is we are trying to use word, make sure that it is not in this stop words in this list, so that we can, it's not going to include these words. So it's going to get rid of this. The reason I have used strip is this list of words may have some trial spaces at the start or at the end. So that's the reason I have used strip, right? If you execute this one, the reason why it was stop words is not defined. All right, it looks like I haven't imported here. I got it. And this is the column. I can see that this list does not contain any stop words. There is another list I have given here, HTML tags. When we web scrap that, like let's take that you have started data from web pages, bunch of web pages. We call it as web scraping, right? There are a lot of tools for it. So when we web scrap data, there is a possibility that it comes with HTML tags. For example, let's take this page. When we web scrap directly, it's going to come with a lot of tags, meta, link, but the actual data is going to sit somewhere in between. If we look at this one, right? You can see that ask question, this is the text that you want, but it is being wrapped in this repeat or whatever the text that we have. So we need to get rid of that. So for that, I have created another list. Where is it? Yeah, here. You can see that I have created a list of words. Basically, I got it from this w3schools.com. So if there is any update, there is no library for that. w3schools.html. You can see that HTML tags, there is something like, yeah, HTML tags list. You can see that this one, right? Let me take the whole thing. I can go to ChatGPT and get me the list of HTML tags. You can see that we got this one, right? Here it's giving even the angular bracket. What we can do is, I don't need angle brackets around it. In fact, I need it in the form of Python list with comma separated. So it's generating all the HTML tags. I can use that directly here. Where is it? Yeah. So I will prepare that list in this way. And same logic we can apply it. So whatever the logic that we have applied for stop words, we can simply replace stop words with tags because that's the list that I want to get rid of. Okay. If word strip not in tags, then this word is going to return. If we don't use this if tag, if part, then it's going to return every word. So we are trying to filter it out right here itself. Okay. I hope you got the logic here. So we cleaned up all the data. We get rid of tags and we got rid of, let me execute this one. This has to list, right? Yeah, we got this HTML tags. And now at the end, again, we need to join back again. We join back these words. So this is basically a list of words. How do we join that? Using join. I've used space as separator. You can see that space. The reason is that every word should be separated with space, right? Otherwise, it's going to combine to one word. So I have used the same apply list. I have not used list comprehension because I need to join back as sentence. I provide this list because every loop is going to be one list, right? This is going to be done by app apply. It's going to act like a function because we have given lambda, so we can write one-line functions. Now we got uh, the corpus without stopwords, without any HTML tags, and without any special characters. It's all been cleaned, isn't it? Any questions on this part? How do we clean that data? Text data especially. This list comprehension with apply and lambda is very powerful. So we need to do that. You can simply copy and paste it, but this is the logic that we need to use. If you want to get rid of any numerical or special characters, we need to use non-alphas because we counted everything into lower. You can simply give small case. We don't require to give capital case, capital A to J. Not write like this. So we're going to replace all the non, this is cap means non, right? So non-alphabets. So all non-alphabets is going to replace with blank. So there is a possibility that it may have even space. So make sure that you have to give space, or else it's going to replace even that one. Okay. This data set. The reason I have given encoding is that it may have some non-English data, so it may throw a Unicode error. So that's the reason I've used ISO 8859. I have explained this in Pandas. So this is going to get rid of all the special characters, convert into lower, all special characters going to fill with blank, and it is going to split into, based on space, is going to split into, it's going to form a list of words. It's going to split based on space. Finally, this is what we got. And this is what we have used here, right? To get rid of stopwords and, HTML tags. At the end, again, we can join back it. On top of this, we can apply count vectorizer. Let me apply count vectorizer on this, and so that you will get an idea. We have a project for it, right? So the input column is this one. Okay. Perform this one and fit process. So it's already, what we can do is we can use the same thing like here. We already have this one, right? Already got in the form of sentences. And this corpus, actually we should not provide a corpus. Instead, it's review. If you look at this now, vectorizer, get feature names out, right? We got a list of it. Like it's not showing all. Suppose if you want to see all, there is option CD option. In ML template, you might have seen this one, right? Max or what, I don't know the exact option. What is max columns? Max columns? None, I think. I'm not wrong. It is max columns or what? PD set option display dot max columns, I think it is. Display dot max columns. Yeah. If I execute this one again, all right. Rows still not giving the complete list. It's saying dot 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 kind of. All right, so we will see that in at least in pandas one. So this is calls, right? Same, we already have X, so we can form a data frame. P dot data frame X dot to array, right? To array, comma columns equal to this calls. This calls I have. I think I have given extra bracket. I can store it in df. There are too many words, right? So it's taking a lot of time. Oh, not a memory to open this page. Oh, so start throwing error. Got stopped because I lack some memory. I don't know. 404 rows, right? So each, yeah, it's a lot of data. Okay, all right. So we'll see another project. I hope you got the point. So we can form a data frame and then start working on it. Let me execute this. Let me give another try. Okay, so I think we got it. You can see that each column being converted as, each word being converted into column name, right? And this data set we are going to feed to algorithms. And it's not the direct one. Of course, there are better ways to do, it's not count vectorizer. Count vectorizer does not help us much. There's something called TF-IDF vectorizer and word to wake or cloud. We're going to have session on word embeddings. We'll get a complete list of it there. What else? Stemming, yeah, stemming is one thing that is, we're going to discuss it now. There is something called, okay. Stemming is basically like testing, caring, cared. So these are all the same words, right? If we take these words directly, right, if without fixing it back to its root word, that is root word for these three words is care. For this get, got, the root word is get. Shine, shining is shine. So if we don't fix it back to its root word, the problem is that each word is going to convert into a column. Then it does not add any value. So having two columns, having three columns just for care, get got, we're going to get two columns. In this case itself, if we can able to fix it back to its root word, instead of five, we're going to get only two. Unnecessary, we're adding overhead, right? So by adding all this. So the whole idea of that is stemming. There are two methods, potter, stemmer, and lematizer. Let me explain the two methods as separate methods. The actual strategy you need to follow is this one. I'll explain both in three cases. Stemming is not really effective enough but compared to lematizer, but let me show you an example. Here you got care, caring, cared is work well. So care, we got. We can simply mention it as set, right? Set, or they can convert back to list. Set is basically, get rid of any duplicates. You can see that we got care, take, shine, got, get. You can see get, got has not been converted to its root word. And taken also didn't work. But shining worked, caring, cared worked, right? So this is one of the methods that we have, but it is fast, but it's not as effective as lematizer. Even lematizer fails in some cases. We will see that. So how do we import that stemmer? The porter stemmer from NLTK stem porter. We have to create object for it. and then we need to apply, we have a method called stem in this, we need to apply it. We have used list comprehension here. A lematizer, LNTK stem ordinate lematizer, we need to have the object same way as we did here. So we need to apply the same thing. One thing is, and the methods may change. The object here is a lemma.lematize. And we need to mention the part of speech. This is a verb, right? So we need to mention the part of speech. There are different forms. Usually we go with verb. So when we go with verb, it is basically got like this. Let me excuse this. Shine. Shine basically didn't work well. You can see that shin, right? Get, K, take, shine. So these, except shine case, the remaining case it worked. Compared to this one, get, got, 1, 2, 3, 4, 5, 6. We have only 1, 2, 3, 4, 5. So it got reduced to 6 to 5. Fine. So even lemtize, it didn't work in this case, right? We need to combine both. So we need to apply stemming first. That need to be fed as input to the lemtizer. Okay. Then this will work like a charm. You can see that shine, get, K, take. Even if it takes time, here we have very limited amount of data, but you may, when you apply on the whole column, then it may take a lot of time. So in that case, even if it takes them, that's fine. Go ahead with this strategy. Okay, then it's going to fix to its root port. So now how many columns that we have saved? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to only 4. So we have saved almost, honestly, we reduce the overhead of 6 columns, right? 10 to 4 means what? So we get rid of 6 columns. Drastically reduce the overhead on the system, right? Any questions?
So what is that parameter position is equal to V?
It's not position, it's part of speech. Part of speech means verbs,
Oh,
nouns,
got it.
pronouns, kind of, right? So I think I have that here. Let me show you. I don't know whether I have it or not. It's a language list. It's a language list. Use it for some other purpose. Coordinate lematizer, parts of speech list. I think there should be a way to get the lematizer list. Looks like not this one. Official documentation. Better go to this example. Coordinate lematizer. Yeah, looks like this is the official documentation. Here again, part of speech. Yeah, you can see that right here. N for nouns, V for verbs, A for adjectives, R for adverbs, S for certain adjectives. So usually we look for ing, ed forms. So that's the reason we have used verb. So don't go with nouns or whatever. Go with verbs. That's exactly where we need to focus on.
Yeah, by default we should have V itself.
Yeah. So we need to get mostly the data. It's going to have different verb forms like shine, shining, shined. Right?
Continuous past tense and also.
Yeah. So past continuous or present continuous or present tense, like those sort of things. Any questions?
No.
Yeah, someone saying something was not audible.
No questions.
So next one is another one, like we need to, or I will discuss it now. We have enough time. So we'll discuss in test classification. Same methodology. Tomorrow we will discuss regular expressions. Another important one. The same methodology. Like just like the way we have used text classification, binary classification template, right? I've used the same template. If you look at this from here, in fact, from here, from time test split onwards, the same classification problem algorithms I have imported. I use the same pipeline, hyperparameters, binary classification, this one. The same algorithm, you can see the same algorithm, the same grids, the CV, same algorithm, same evaluation matrix. So I've used binary classification because this more of binary classification. So I mean to say, when we look at the data, review data, it's either positive or negative. That is what we need to find out, right? Watching data is a positive or negative. So I use the value counts and make sure that it is a binary classification. So what is something that is new here? The pre-processing step. So we got the data set and make sure that we don't have any nulls. We don't have any duplicates. The same pre-processing stuff that we applied in text classification. The only difference is from here onwards. We already discussed about this, right? Convert to lower, special characters, remove it, and split it into list of words so that we can get rid of HTML tags and stop words. And we need to limitation part I have explained with an example, but this is the real one. I mean to say, you can see that we are applying for the whole column. Apply sentence every is going to be every sentence, isn't it? So that is going to be applied. We are going to apply on that. So lemmatize stemma dot. I am going to provide each word. So this is going to get the root word. So this may have duplicates, but so this may be set it back to root word. This may have duplicate words repeated. But thing is that when we apply on the TF-IDF factorizer is an alternative to count factorizer. This is much more complex compared to count factorizer, and this is much more better option compared to TF-IDF count factorizer. Let me explain the logic. It's basically two components, term frequency and inverse document frequency. So it's going to term frequency in the sense, let's take a word. We need to find out how many times that particular word being repeated in that particular document. And this IDF is basically for the whole corpus. Corpus is nothing but bunch of documents, right? So how do we calculate IDF? It is 1 plus n, the number of documents. Let's say that we have 100 documents in a corpus. It's going to be 1 plus 100 by 1 plus DF into DF of document frequency of the term. So document frequency sense, how many times that particular word being, how many documents that this particular word has. Okay, let's take that a key word. Let's take the times. Times is a word that has been repeated in 7 out of 10, 7 out of 100 documents. Then we need to mention the 7 here. Okay, so this is not in any calculation as such. It's just 7 as it is. Then it's going to be 1 plus 100 by 1 plus 7. It's basically log. So whatever the log value you get, we need to multiply with this one. We get TF-IDF. So it's going to do for every word. Of course, we not do it manually. Just like the way we have used count factorizer, we need to use the same kind of object like this, same fit transform on this whole column. We're going to get similar to count factorizer, we're going to get a matrix and we're going to get the column names. We need to form the data set, and this data set need to be fed. Where do we feed that one? Here, this is from the label column, the target column. So this is only for the input data. We're not going to feed this review column as it is. We're not going to feed this review column. Instead, we are taking this as the input data set. So we already have X, right? We have Y column. So we not split into X comma Y, except that we need to convert this text data. The target column has positive to 1 and negative to 0. And then we can directly pass this. Usually what we do, so we split into X comma Y, right? So we already prepared X here. And then we are going to use that in train test split to get X train X test, Y train Y test. And thereafter, with the same logic, if it has two classes, if target column has two classes, then we're going to apply, we need to copy the binary classification logic. If it is multi-class, use multi-class logic. That's all. Okay. Any questions?
Sir,
This,
then you,
yeah, go ahead.
yeah. Sir, PF means it is applicable for each word in the corpus.
Exactly. So it's going to apply for each word and going to convert into columns. And for each word in that particular document, every row is a document, right? You're going to, if it is there, it's going to give some number. If it's not there, obviously it's going to give 0. So these words are not being there in that.
And that
So
number should be any value, or it should be 0 to 1.
usually it's going to be between 0 to 1, because whatever the value that we get, going to be between 0. You can see that 0.070673. Okay. This is much better method compared to count vectorizer, but this is not the de facto standard right now. So we use much better methods compared compared to TF-IDF vectorizer. I will see that later. So any questions in today's session? I think I will better stop here, because there are a few other topics like word embeddings or regular expressions that need dedicated session on altogether. So any questions in today's session?
So, sir, then when any text data we will get, the first we have to do remove the stop words. Then after we remove any special characters and all those things.
Yeah, HTML tags, special characters. If you want to add something, like you can do it. We need to split into this one so that it is going to be more user-friendly to list comprehensions. We can easily use list comprehension.
Okay.
And then we can join back again at the end. We already joined back, right? Yeah, here we have already joined.
And sir, if the document is very big, can I divide it in the batch and do it like that, or I need to do at a time?
Again, it's like you can take it in form of chunks and you can keep adding it, right? You can do that. We already discussed concat across
Yeah,
rows or
contact.
across columns, right? You can combine all the methods and you can do that.
Okay.
But one important thing that I missed here is there is something called max features. Suppose if you have a large amount of data and you want, instead of doing it batches, there's something called max features. Suppose if I mention max features equal to 200, it's going to select only the 200 important features. It's not going to select all the columns. In this case, I have not applied anything. So I got all the columns. Here dot 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 means there are a lot of other columns. It's not just this one. Dot dot means there are many other columns too. So you better use this one rather than doing it in chunks. This will work like it's going to pick only the important columns and it's going to apply that. If you don't apply it, it's going to convert every word into a column.
Sir, here is the question, sir. You are saying
Your
that
voice is not
maximum.
clear. There is a problem with audio. So
Now, sir, it is clear.
yeah, better.
Okay, sir. After clearing the data, means whatever the important thing is there in that corpus. So then after, if I select the feature, means how I can decide which things are important in that corpus.
That's the reason we have this option. So we don't know by just by looking at the data. We have this option max features, right? Or else we can even apply feature selection methods, statistical methods. And forget about embedded methods. We can apply feature selection methods, filter methods, and we can make sure that which column is better. But it is better to use this embedded option, max features, rather than using filter methods. It's your choice. All right, that's it for today. I'll continue tomorrow. So practice it, like I'll upload the script immediately after the session. So you can try to execute it. Right. Thanks for joining.
Thank you.
Thank you.